This Fizzcast involves current flowing in an AC circuit. Pause the video and read through the question carefully. Now we can begin with our interpret step, trying to understand exactly what's going on in this kind of problem. You should be able to see that we've got a voltage indicated in this problem, and we're being asked to calculate something to do with current. So we'll need some relationship between those two quantities, and that tells us we should be using Ohm's law. And indeed, in this case, Ohm's law for AC circuits, which is a little different to what we use for DC circuits. Moving on to our develop step, where, as we'd quite often like to do, will involve a diagram. This question's already given us a diagram, so we can probably just refer to the diagram, maybe annotating it with some of the values given in the question. For example, our resistor here, we're told, has a value of 150 ohms. Our capacitor here is 47 microfarads, and the voltage source here has a peak voltage of 25 volts and is running at a frequency of 60 hertz. Now, with those values given, it's important we can understand the relationships between them. Using Ohm's law for AC circuits, we know that the voltage here connects to the current multiplied by the impedance. Now, these voltages and currents, they need to either be both peak or both RMS values. For the time being, we might write that down as peak values because that's what the question tells us. But of course, we're being asked for the RMS current, so we'll need to remember that the RMS value here is 1 over root 2 times the peak value. What is this impedance that we need to think about? Well, it involves both the resistance and the reactance in the circuit. And it's going to be the square of the resistance plus something to do with the difference between the inductive and capacitive reactances squared, and we'll take the square root of that whole thing. Now, this problem is a little bit simpler because we don't actually have an inductor and a capacitor, we simply have our capacitor. So we'll just involve the capacitive reactance squared in our impedance calculation. What is that capacitive reactance? It's going to be 1 divided by the angular frequency times capacitance. In this question, we've been given the actual frequency, not the angular frequency. So let's remember that's going to be 2 pi times the frequency for our angular frequency multiplied by capacitance. Now, with all of those relationships, we're ready for our evaluate step to actually do some calculations. The first thing we might like to do is to find out the value of that capacitive reactance. It's going to be 1 divided by 2 pi times the frequency, which we're told is 60 hertz, multiplied by the capacitance, which is going to be 47 microfarads. So we'll need to write that as 47 times 10 to the minus 6, keeping everything there in SI units. When we do that calculation, we find a value of 56.4, so that's going to be in ohms. Now, with that capacitive reactance, we can calculate the impedance for the circuit. Of course, the reactance and the impedance here depend upon the frequency, so it won't just be an absolute value, but the value that's happening when we've got a frequency of 60 hertz, and that will again be the square of our resistance, which doesn't depend upon frequency, plus the square of our reactance, which we've just calculated for that particular frequency, and we're going to take the square root of that sum, and when we do that calculation, we'll find an impedance here of 160.3 ohms. And you can see I've been keeping 1 or 2 extra significant figures in these calculations. If you look at the question, my limited precision there is only to 2 significant figures, and that's what my final answer needs to be. But to avoid any rounding errors, I'm keeping some more significant figures in my intermediate results here. And so now when I come to calculate my current, it'll be the peak current here by Ohm's law will be the peak voltage divided by the impedance. That's going to be 25 volts divided by 160.3 ohms, and I do that calculation and I find it's 0.156 amperes. That's my peak current. Not quite the answer yet because of course the question's asked me for the RMS value for the current. That's going to be my final answer there. That's going to be 1 over root 2 multiplied by my peak value 0.156, and that gives me a value of 0.11 amperes to 2 significant figures. There's my final calculation. Now, of course, it asks for the current through the resistor. I need to double check on my circuit here. This is a series circuit, so my current that's flowing at any point in the circuit, say for example through the resistor, will be the same as the current through the capacitor, will be the same as every part of my circuit. It's a series circuit. So this is indeed the RMS current through the resistor. I'll need to add an assess step here just to do a quick check of part of my answer. There's many things I could do, but I might just think about what my current variation with time is actually doing here. What my current is doing is, of course, varying sinusoidally in some way. And I'll remember that my peak current is the largest value my current takes away from that zero value, but my RMS value here must be something less than that. So I need to double check that in my calculation it did come out that my RMS value was less than my peak value. And if you look at those values there, 0.11 is definitely smaller than 0.156, so at least that part of my calculation does seem consistent.